Hi everyone, this is Zaid from Team Blaze IITR and this is our app Quack Trace briefing for the CodeFundo 2018. So in CodeFundo 2018, we were given the challenge to build a technology that could predict or manage natural disasters. And from these two choices, whether to predict or manage the natural disasters, we choose the management of the natural disaster. And the simple reason for this choice is that we want to make a technology that can provide a foolproof mechanism which can save lives. Scientifically, the tectonic plates movement or the earthquake cannot be predicted. So the best thing which we can do in prediction is to use the previous seismic data of the regions and to find the probable earthquake. But these probability could lead to chaos and could cause more death and trolls. And with the simple aim to save more lives, our app is based on the management of the earthquake. A major portion of the people who died in the earthquake are those who were trapped under the debris, and this is because the rescue team cannot locate them and get them out of the debris. And this is where our app can come handy. So the basic idea of our app is that it could be a government app where the government can have a server, and in our case it is the Azure server. So our app stays in the background and at regular interval of time it fetches the data of the latest earthquake from the USGS server, and at the same time it finds out the user location, and if the user location is in proximity with the earthquake location, which simply means that the user is in danger, and so the user location is sent to the Azure or government server so that the rescue team can find out the user location and can rescue him. Here is a small demonstration of our app. The default app checks for the earthquake every 1 hour, but for demonstration we have set the time to be 10 seconds. The app sends the location to the server only when the user location matches with the earthquake longitude plus minus 0.5, but for demonstration purpose the app sends location whenever there is an earthquake irrespective of its proximity to the user. The default app sends location only when the earthquake magnitude is greater than 5, but for demonstration there is no barrier of earthquake magnitude. Our app demonstration starts from here. This is the USGS API from which we are getting the latest earthquake activity. User opens the app, enter his details, which contains his name, phone number of the relative to which the rescue team can contact later on. Click on the start button, after which every 10 seconds app picks victim location and matches it with the latest occurred hazardous earthquake in the proximity of user. User provides necessary permissions to the app. The app matches for the user location in a span of 10 seconds. It seems the user location has been matched with the earthquake location, and the user longitude, latitude with his name and his related phone number is being sent to the Azure server, which can be seen in the table on the right of false column. If the user is safe, he can let it know to the rescue team by clicking the OK button, which changes the safe column of the table from false to true, so that the rescue team can focus their time on the people who are really affected. So here are some improvements that can be made in the app future updates. The app currently uses the GPS location. In future updates, the app can use the IP address to trace the user location. The app can be optimized for battery consumption, and we can use foreground services to keep the app running in the background for longer time. So this was all about our app Quack Trace. Thank you.